This video on convergent and divergent series. By the end of the video, you should be able to answer the question, what is the difference between a convergent and divergent series? So, the terms convergent and divergent. A convergent implies that it's a sequence of partial sums that approaches a limit. So when I add up all the values in the sequence, making it a series, it will approach a number. It just doesn't take off to infinity. We saw that with geometric series that had a common ratio less than 1. For instance, the geometric series of, let's go 12, 6, 3, 3 halves, 3 fourths, 3 eighths. If I add all these up, we will, and then keep going till infinity, we will approach a number. Let's see what that number is here. Hold on. So I'm calling up my calculator so that we can start crunching some numbers and see what's happening here. As I add my numbers together, I have 12. Hello. If I can type correctly, 12 plus 6, that gives me 18, plus 3, I'm going up by smaller amounts, 21, plus 3 halves, so 3 halves, that gives me 22.5, so I've gone up an even smaller amount, plus 3 quarters, going up an even smaller amount, 23.25, plus 3 eighths. So I'm still in that 23 range now, going up 3 eighths. The next one, if I kept going, would be plus 3 sixteenths. So I'm still in that 23 range. I'm getting closer to 24. If I add on another one, plus 3 32nds, I'm even closer to 24. And as I continue this and go and go and go, we see that I approach the number 24. So that would be my limit, okay? So we saw that this is a geometric series with a common ratio r of 1/2 because every time I multiply by 1/2 to get to the next one. We also saw a divergent series where we don't approach a number like we did in the last one. It just spins out of control kind of and just gets bigger and bigger and bigger. And we saw that with geometric series that had an r value, an absolute value of r greater than 1. So the absolute value here of 1/2 was less than 1. So we had a convergent series. It approached 24 as a matter of fact. If I had another one, say this went, instead it went like 2, 6, 18, and then kept on going multiplying by 3 every time, my r value would be 3, and the absolute value of 3 is not less than 1. That's false. And so this would be divergent. So we saw that before in geometric sequences and series. And we also know that arithmetic series will be divergent by nature as well when we're adding to get from one term to another. But what if we don't have an arithmetic or geometric series? What if it's something else? Well, then we have this thing called the ratio test. And let me put it in shorter terms. You can read through the big long definition if you want, but in shorter terms, if we do a calculation where we take the limit as n goes to infinity of 2 terms in this series, 2 positive terms, we'll call them a sub n for the first one, and then the next term, a sub n plus 1, that produces a rate r, then we can come up with a couple different situations. The series will be convergent if r is less than 1, and divergent if r is greater than 1. However, if r equals 1, the test gives us no information. It's basically a wasted time. But sometimes knowing that we don't have any information about something is useful as well. Sorry for the bell. So let's move on and see how this is going to play out. Our first example examines this series to determine if it is convergent or divergent using the test that we just talked about. So I first begin by determining an expression for a sub n and then a sub n plus 1. So as I look at the values in my series, the first number will be where n is 1. That's my first term. This will be my second term, my third term, and my fourth term. I need to think to myself, what can I do to each of these values to get that term value? So what can I do to 1 to get 1/3? That would do the same thing to 2 to get 2 over 3 to the second, so on and so forth. What I have determined is that a sub n would be my n value divided by 3 to the n. Okay? Now, why does that work? Well, if I put in 1, so if I take my n value of 1 and drop it in here for n and here for n, then that would produce 1 over 3 to the first, which is what my first term is. If I took my 2 and dropped it in for n here and for n here, that would give me 2 over 3 to the second, which is what I have here. If I put in 3 for n here and for n here, that would give me 3 over 3 to the third, which is what I have here, and same thing for 4 and so on and so forth. So that works for my a sub n term. My a sub n plus 1 term would simply take and replace where I have n with n plus 1. So I'm going to have n plus 1 over, sorry for the bell again, over 3 to the n plus 1. So I've taken and replaced my n's with n plus 1. Now the ratio test asks me to take the limit as n goes to infinity of a sub n plus 1 over a sub n. So that will produce, that's going to translate into the limit as n goes to infinity of n plus 1 over 3 to the n plus 1 all over n over 3 to the n. Now, instead of dividing by a fraction, I will translate that into multiplying by a reciprocal. So I have limit as n goes to infinity of n plus 1 over 3 to the n plus 1 times the reciprocal of my denominator, 3 to the n over n, reciprocal. Let me start this on a fresh page so I have some room to work. That's going to want to copy that over. Let me try that again. I have most of it, copy the rest. Copy, new page, paste. That's not what I wanted to do. Let's go back again. Apologize. Copy and paste. There we go. Good. All right. Now, this part and this, when I have like bases, I subtract the exponents, as we learned back in algebra. So this is going to leave me then with a simplified format of n plus 1 up in the numerator and a 3 times n in the denominator. Now, the next step that I do is I will take and let's find out what the limit is. I always like to think of limits, and a lot of people do, as what happens when I plug in really big numbers. So what would happen if I plugged in 1 billion for n? Well, that would give me 1,000,000,001 over 3 billion, which is really like thinking about a billion, because that extra 1 becomes insignificant. So a billion over 3 billion. Well, 1 billion divided by 3 billion would just give me 1/3. So that is my R value, and according to my test back here, that is less than 1. It says if r was less than 1, it's convergent. So this would be a convergent series. And that was because r was less than 1. Okay, let's take a look at another one. Same thing, looking at this series. Let's write our two rules.
Attention students, the building is now closed.
Sorry for the announcement.
All students must exit the building at this time. You may only remain if you are with a teacher, coach, or staff member. Again, all students must exit the building at this time. Please clear the hallways. Have a good evening. You may only remain if you are with a teacher, coach, or staff member. Thank you.
Sorry for the interruption. I have to love the office announcements. So as I look at this, n is equal to 1, 2, 3, 4. So it becomes apparent that the numerators are just my n values. The denominator is actually n plus 3. That will give me each of these. So 1 plus 3 gives me 4, 2 plus 3 gives me 5, 3 plus 3 gives me 6, so on and so forth. Here I go a sub n plus 1, replacing my n's with n plus 1. So now I've got n plus 1 down here, plus 3. And I take my limit test, limit for the ratio test, limit as n goes to infinity of a sub n plus 1 is going to be n plus 1 over, now this bottom part here, that's really just like n plus 4. So I'm going to replace this with n plus 4 to shorten things up. Down in the denominator, I've got n over n plus 3. Fantastic. So let's take some limits now. I'm going to speed up the process a bit. So the limit up top is I take the limit of n plus 1 over n plus 4. That would be, if I put in a really big number, like a billion again, I like that number, I get 1,000,000,1 over 1,000,000,4. Again, with a big number like a billion, 1 doesn't really mean much, and neither does 4. So I basically have 1 billion divided by 1 billion. So that would come out to be 1, 1 billion divided by 1 billion. Same thing happens in the denominator down here. So downstairs here, I've got 1 billion divided by 1,000,000,3. The 3 is really insignificant with numbers that big. So that also comes out as 1. So my limit comes out to 1. So r is equal to 1, which back in our definition stated that the test provides no information. So this would be a situation where the test is inconclusive. We'd have to turn to other means. The third situation would be if I got an r value that was greater than 1, which would mean it's divergent. But we don't need to go through that. Hopefully this helps you. Good luck. Have fun.